Chapter 1 of Linear Integrated Circuits. We are going to be discussing the general amplifier concepts before we move into chapter number 2, which will be specific to the applications of operational amplifiers, starting from chapter number 2. So in this chapter, we are not touching up operational amplifiers yet. We're just going to be discussing the basic concepts of amplification, frequency analysis of amplifiers, and some other topics. So what is an ideal amplifier? In this course, we will be discussing ideal amplifier, ideal operational amplifiers. We will also be looking at some of the limitations of ideal operational amplifier, but you will see in chapters 3 and 4, or chapter 3 I think, actually both chapter 3 and 4, that those limitations actually really don't make much of a difference as how do you use the operational amplifier in the ideal mode. Operational amplifier, most of the time when you analyze it, it is analyzed using ideal conditions, and actually the analysis is pretty close to the actual physical conditions. So any amplifier that produces a signal at the output which is a replica of the input, that is the exact shape of the input. The only thing that can be changed is the amplitude and the phase, but the shape should not change. That amplifier is called a linear amplifier or ideal amplifier. Generally the gain of the amplifier is represented by A, but you can represent it by anything. A is just a general symbol that is used for the gain, and gain of course is how much output has been increased with respect to the input. That basically represents the gain of the amplifier or the circuit. As you can see, there are two figures over here, and in both figures this is the input, for example, and this is the output, and as you can see, input and output shape is the same, but each value of the input is being amplified by a factor to produce the output. Likewise, in the figure where you have a sinusoidal signal, observe that the output, which is blue, is amplified with respect to the input. However, the phase of the output is 180 degrees out of phase with respect to input. When the output is low, the input is high, and vice versa. So it is possible that your output will have different phase, but as long as the shape is the same, that means the amplification is linear and you are using an ideal amplifier, let's say. Now you have used the dependent sources in circuit analysis, and those dependent sources are basic form of linear amplifiers. Four sources that you use: voltage controlled voltage source, that is a voltage source whose voltage can be controlled by another voltage in the circuit. Current controlled voltage source, similarly it's a voltage source and its voltage can be controlled by a current that is flowing in some part of the circuit. And likewise you have two current sources: voltage controlled current source and current controlled current source. So this is, you already are familiar with the symbol of the dependent sources. As I said, you discussed that in circuit analysis. It's a diamond symbol with the positive, negative for the voltage source, and of course the arrow in the direction of the flow of current for the current source. So you have the voltage controlled voltage source. The voltage of this source is controlled by the voltage that is produced between the input Vi, and it is multiplied by your the gain of the amplifier, which is A. So that's your voltage controlled voltage source. If you go next, you have current controlled voltage source. Similar concept, that you have a voltage source and the voltage of that source is being controlled by the current that is flowing in the through the input terminals, or per se anywhere in the circuit. It does not really matter, right? And then you have the third one, voltage controlled current source. So now you have two current sources, and this, in this case, the current source is dependent on the voltage that is produced in some other part of the circuit. And this is similar to MOSFET, because in MOSFET the current that is flowing from your drain to source depends upon the voltage that you give to the MOSFET between gate and source. And the final is current controlled current source. Again, the current of the source is going to be dependent on some other current flowing in the circuit, and it is similar to a BJT, bipolar junction transistor, because the collector current in bipolar junction transistor depends upon the base current, and it is multiplied by the current amplification ratio, which is beta. So all these sources can also be considered as uh, your amplifier circuits. In the next video, we'll discuss the complete amplifier model.